Hey guys, what is going on? Hope you're doing well. Today we're going to learn about how to use machine language, QTSpim in this case, to basically type out 10 random numbers and use those 10 random numbers to sort ascending order, sum, an average and a median value from said 10 numbers. Firstly, let us introduce my group mates.
Hello, my name is Irfan bin Izzat. I'm from FTMK BITC S1G2.
Hi, my name is Nur Zawani binti Naazi from YMDITC S1G2.
Hey guys, what's up? My name is Lim Rong Wei. I'm from BITC S2G1. Nice to meet you.
Okay, so starting off, all these prompts will be basically any of the words used. For example, when this prompt is used here, for example, it will print out this program is created to output data in ascending order, calculate sum, mean and median, and then there will be this space here. Please enter 10 random numbers. Yeah, that's how it will work. So we'll start off with the main. The execution starts here, the main. So the system will call to print a string, load immediate this code, and you will need to load address. You will need to use this prompt, which will go back here, like I said just now, which will print the prompt on the terminal. Syscall will print this command out, so it will print this text out. Okay, so what after this, basically we need to load two zeros into these two numbers for our basically our A and B. So Ori ST5 and S00 Ori S, yeah, you get the point, you can read. Okay, so after that, basically we will need to initialize the array for the other variable, which is SS1. So doing this will initialize the array. Okay, for the loop will require lisv05, which will basically read 5 as an integer, and then your syscall, which is it will print out this thing, and then after that it will store word sv0 0 ss1, which will basically store ss1 into the array, and then after that you will add immediate ss1 4, which will increment the address of the array, add immediate ss1 1, which will increment the loop, basically go from the fourth number to the first number, and then it will branch not equal st1, then the loop, which will mean branch the loop if register st1 is not equals to 10, and then after that you will need la ss1 array, which will initialize the register ss1 with the address of the array, and sub st1, which will basically reset as the st1 value to 0, because we will need to use it yet again. Okay, so continuing on, we have order 1 and order 2. So for this one, we'll start off with branch if equal bq st2 9 order 2. So what this means is if the branch is equals to st2, which is 9, basically the ninth value, you will go to order 2, which is here, this code right here. If not, then you'll stay here, I guess. And then you load word st3 0 ss1, and you load word st4 4 ss1, which means you load the value of this array element into st3, and you load this array element into st4, the value of this array element into st4. Okay, and then same code as above. As you can see, add immediate ss1 4, add immediate st2 1, which means you increment the address of the array and you increment the loop's counter. So add another 1, so from 9 to 10, for example. So BLT st3 st4 order 1, which basically means you set the numbers in ascending order. So this is the important one, important code. So and SW ST3 0, SW ST3 -4, which will mean store address of array in SS1 into register ST3, store address of array in SS1 into register ST4, and then you branch not equal to ST2 9 order 1, which means that if the branch of order 1 is not equal to 9, it will go to order 1. Yeah. Okay, so for order 2, the second last order for ordering the numbers is load address SS1 array, which means initialize the register of SS1 with the address of array. You will yet again add immediate ST1 ST11, add immediate ST2 ST1 0, which means you increment the loops counter, and you set the loops counter of j equals to I. For this is the last one, so you not normalize everything. So branch not equals to st1 9 order 1, which means branch to order 1 if register st2 is not equals to 9. So that basically jump it back here. So load li sv04, basic system call to print string, and your LA SV0 prompt 1, which will basically print prompt 1 on the terminal, which is this prompt. Okay, and then it will syscall, and then it will LA SS1 array, which will initialize the register of SS1 with the rest of the array, and then you sub ST1 with ST1. So it basically ST1 minus ST1, and that value will become ST1, which basically makes it 0 because we need to reuse that value again.
In order final, we want to print out the number that we exchange into ascending order. We want to print the number out to allow the user to see what they type in. For this code, li register v0,1 is to print out the integers following by lw register 0,0 in bracket register s1 close bracket. Load this address into S0 and we want to print out using syscall. They increment the address of S1 by 4, then we increment our looping by 1. Li register V0,4 followed by LA register A0, space is a code so that we want to print out a string of space, meaning that we want our number to have space between them. After that, system call to print out the space. The next code, branch not equal or better known as BNE register T1, 10 is if T1 not equal to 10, it will then proceed to order final. It will also loop 10 times until T1 is equal to 10 and each integer have a space in between, following by sub T1 by T1 to set T1 to 0 because we want to use it again. Then we initialize array register S1 again because we want to use it later on.
After that, we want to find the sum of all integers given by the user. For the code of sum, we load the number into register T5 by the LW register T5, 0 open bracket register S1 close bracket, and then we add them into the register S2. The increment address of S1 by 4 followed by the increment loop of 1 by the T1. If the register T1 not equal to 10, then the code will go back to the sum because we use the branch not equal, which is the BNE register T1, 10. Next, we use load immediate register V0, 4 to print out the string with the load address register A0, sum by the syscall. We move the integers register S2 into A0 proceed by the LI register V0, 1 and we use the syscall again to print the integers out. Just like before, again, we sub the T1 by T1 to reset the T1 equal to 0, followed by the initializing of register S1 into array address.
Okay, to calculate out the average, we need to print the string out, and then using lisv04, and then using la sa0 average, you print the average on the terminal. This will print this will print this line of words out, and then you print it out. So syscall to print it out. Add immediate ss3 ss3 10. So basically you set ss3 to 10. Basically this is the to be divided value. So you divide ss2 by ss3, which is 10. So divide this by 10, which will basically calculate out the average. So if we use mf low and mf high in order to differentiate between because we might have decimal places. So this is a quotient and this is a remainder. This will be the full value and this will be the decimal points, the 0.0 something, whatever it is. So we move SA0 to SD3, basically move integer into this register SA0, and then you will call for a code to print the integers, and then you will syscall, and then you print it'll call to print the string sv04, and then you print a dot, which is this. So basically, and then after that you will print move sa0 into sd4, and you print out in li sv01. This will basically print out the decimal place. So this prints out the full value, the 10, 12, whatever it is. This will print out the dot, the decimal place, and this will print out the decimal points. Now following on to the median. The median will basically system call to print the string out, li sv04, lasa0 median basically prints out the median on the terminal, followed by syscall, basically this median value for number is. Okay, so followed by that it will load word sd6 into 16, load word s16 into sd6, sorry, and you load word 20 into sd7, so load word into register 6 sd6, and load words into register sd7. So you add sd6 into sd7. So basically sd6 equals to sd6 plus 7, and add immediate ss4 which will basically set ss4 equals to 2. Divide sd6 by ss4. So basically this 2 divided by 2. So yet again you might get decimal places. That's why there's mf low, mf high, mf the full value will go into sd3, full value decimal points, sorry, will go into sd4. So here we have multiply of sd4 multiplied by 10, and then after that you divide it by 2, and then for this is for the remainder. So you move sd3 into sa0. So move this, load immediate sv01. So basically this is a call for printing the integer. So you print the full value first, the quotient first, and then you print out the dot again, and then it will move the integer into from sd4 into sa0, and then you print it out, and this will be basically this multiplied by 10 divided by 2. Basically this is the decimal value. Okay, and then you after that, when it's all done, you'll exit, basically call code to terminate, and you'll syscall, and then you'll end. that's all for now. Yeah, so for that's everything that we run. Okay, thank you. Have a nice day.